Okay, 7.5, B as in Bravo. One of the things I do want you to make yourself aware of, maybe write down in your notebook or something, is top of page 615. It gives you the 3 steps as far as graphing parabolas. The first one is if you're given, okay, y equals ax squared plus bx plus c, an equation in that form. First step is that y, where it crosses the y-axis here, is going to be whatever number c is. Second part is to find out where it crosses the x-axis. Where does it cross this line right here? We are going to take our equation and set y equals to 0 and use, so there's our equation. We're going to set it equal to 0. We're either going to factor, which remember you make it into 2 binomials like we did in the first example, where you do this, and then solve. You may use the quadratic equation. Negative b plus or minus square root of b squared minus 4ac all over 2a, remember that, quadratic equation. And you can also complete the square. I might show you how to do it completing the square, but we'll see. So that's how you find where it crosses the x-axis. All right, the next part is the vertex. Remember, the vertex is x equals negative b over 2a. And once you find out what x is, you take that into the original equation, and that will find y, and that will give you that vertex, that one point where it changes direction. So anyway, we're going to use these 3 steps in order to continue on doing these. We did do those in example 1. Let's continue with example 2 and get started here. So we have an equation where y equals negative x squared minus 2x plus 3. Now, if you want, if it makes it easier, you can put a 1 in front of that x so that it's negative 1. Sometimes that's easier because that is our a, this is our b, and that's our c. And remember, this negative is part of our b. Okay, so first of all, let's find out where it crosses this line here, the x-intercept. And we do that by making y equal to 0. And we are going to get rid of this negative. And remember, to get rid of that negative, we just get rid of it. But we have to change the sign of everything. Okay, so it's a real easy fix. Basically, what we're doing is we're multiplying both sides by negative 1. And that gets rid of the negative there. But it's easier just to change signs. Okay, then we're going to see if we can factor it into 2 binomials. If we can't, we're going to have to use quadratic formula. But since this is early in the lesson, we can. So therefore, my x is going to be negative 3, and my x is going to be 1. So I'm going to graph those, negative 3 and 1. So one of the things that you know based on that is that your asymptote is halfway between these two. So we're going to actually find the asymptote, but I know that it's going to be at negative 1 because it has to be halfway between these 2 points that we found here. Okay, so let's go ahead and find the asymptote. Remember, the asymptote is x equals negative b over 2a. So what is my b in this original problem? Negative 2. So negative 2. So this negative right here is this one. This negative here on 2 is from up here. Okay, and that's going to be over 2a. So 2 times negative 1. So that equals 2 over negative 2, which is negative 1. So that's what we found to be true there. It's always good to check it just to make sure. I don't want to give you too much of the easy way out. All right, so that gave us our 2 of our 3 steps. And let's go to the third step, and we'll be done as far as finding out what we're needing. So what we're needing now in this next part is we need to find out where along this line this parabola turns direction, the vertex. Okay, so the way we do that is we take this -1 we found, and we're going to put it in the original equation and see what we get for a y. So again, because our asymptote was -1, let's go ahead and put that in for x minus 2, -1. So this is going to be squared, so -1 times -1 is 1, times -1 is -1. This will be plus 2 plus 3. So y equals 1 plus 3 equals 4. So I know my vertex then is along that line right there. And that gives me enough information that I can draw this. And one other bit of information. Remember y equals c. This is my c. So I know it's going to cross this y-axis, sure enough, at 3. So there's another free point right there. And then it's 1 over from our asymptote. So we know the other point is going to be 1 over this way at the same y value. So it gives me a whole bunch of points knowing that it's going to be the same on both sides of that asymptote line. All right, so let's keep going here with example number 3, which is y equals 3x squared minus 6x plus 1. Okay, so let's find the x-intercepts. Let's find where this crosses this line here. So remember, we're going to put 0 in here, and we have 3x squared minus 6x plus 1. Okay. Now, as you look at this, you realize that that does not factor into two binomials. Okay, so you knew it was going to get a little bit tougher. It wasn't always going to be that easy because there were going to be some problems that didn't fit. All right, so what are we going to do? That gives us no other option except -b plus or minus the square root of b squared minus 4ac all over 2a. Yuck. So one of the things, before I do this, one of the things that I always want to remember, if it does not factor into two binomials like the last two did, and I have to use the quadratic formula, remember the last lesson we talked about the discriminant? I'm going to do this part of it first, just to see what kind of an answer I'm going to get for x. Because I want it to be a number that I can graph here on this line. You know, I'd like it to be a 1, 2, 3, 4, you know, a -1, 2, 3, 4, something that makes it real easy. So let's do the discriminant first, see what I get, and that will determine where this parabola is going to cross the x-axis. Okay, so let's see. B squared, that's going to be -6 squared, which is going to be 36, minus 4 times a times c is 1. That gives me 24. So that means the number that is going to go under this radical sign here is a 24. Do I know the square root of 24? No, it's an irrational number. So therefore, the place that this parabola is going to cross x is going to be some weird decimal here. So let's just skip that for right now. If you get something weird, like the square root of 24, and you know that you're going to have a radical, if this were 36, it'd be easy because the square root of 36 is 6. The square root sign goes away. Life is good. But because we can't take the square root of 24, we're going to have a mess. So let's pause on that. And that's what I suggest doing. Finding out if it's going to be a pain in the neck. If it is, pause for a while and do some other things. And rather than use the quadratic formula, let's see if we can find some other points on the graph. So let's look for the vertex. Vertex is pretty easy. X equals negative b over 2a, which means it's going to be negative 6 over 2 times 3. So it's going to be 6 over 6, which equals 1. So I know my asymptote is going to be at 1. Okay, then I take this 1 and I put it back into the original equation. So y equals 3 times 1 squared minus 6 times 1 plus 1. So 3 minus 6 plus 1 equals, 3 minus 6 is negative, 3 plus 1 is negative 2. So I know it's crossing, or it's going to turn direction at 1, negative 2. Okay? So I did find one vertex. Now I also want to find out where it crosses the y-axis. It crosses the y-axis right here. And again, I know that it's going to cross, I'm going to go over the same distance. So again, same height, and it's 1 over from there. It's going to be 1 over from there. So that gives me another point. So right now, for the most part, is I have 2 points, 0, 1 and 2, 1. And I also have my vertex, which is 1, negative 2. And that's really pretty much enough in order to graph this. I don't have to be exact. I just want to get an idea of what it looks like. And that also means that I did not have to find these values here. Now, later on, there will be some times where you are like, what is happening where it crosses the x-axis? And you will need to find that out. But where we're at right now, not really that significant to be able to do that. So that is example, which one was that? Example number 3. All right, so let's keep moving. So this is example 4. So let's look real quickly here. It crosses the y-axis at negative 5. So we can put a blue dot down there at negative 5. We know it crosses there. Let's go ahead and make this y0 so we can find x. And one of the things I do want to remind you, because this minus sign is in front of our x squared, that means it's going to open this way, or open down. So we know that. So later on, when we get there, we're like, okay, we know what it's supposed to at least look like. All right, so let's see what we got here. Let's see where it's going to cross the x-axis here. Okay, so again, you have to factor this to find out where it's going to cross the x-axis. This does not factor. So we're going to have to use a quadratic formula, but the quadratic formula is a lot of work. So before we do that, let's find the discriminant. That will tell us what our x value, where it crosses, is going to look like. So if you cannot factor the equation into 2 binomials, like we've done before, let me remind you, like this, you have to use the quadratic formula. And before you use the quadratic formula, find the discriminant, because look what happens here. B is 6 minus 4, A is negative 2, and C is negative 5. Plus 8 times negative 5, because this negative and this negative made a positive, 36 minus 40. This gives me a negative 4. That means when we write our quadratic formula, this part in here is equal to negative 4. What do you know about taking the square root of a negative? What have I told you? That negative turns into an I. So we end up with an I out here and the square root of 4. When we get an I in our equation, that's an imaginary number. That means we cannot graph it, which means that this parabola does not cross the x-axis because it's imaginary. So rather than doing the whole quadratic formula and finding an answer that has an I in it, we just did the discriminant to find out that it's not going to cross the x, so we don't even do the quadratic formula. So we only had to do a little piece of it to find out what our answer was going to look like. And come to find out, we don't have to do the work of continuing on. So that's the reason that you found the discriminant a couple lessons ago, is so that you could find out what your graph is going to look like without doing all the work. So we didn't have to do that. So yay, that saved us a bunch of time. So let's see if we can figure out what the asymptote is. So I'm going to use my x equals negative b over 2a. And my negative b would be negative 6 over 2 times negative 2, which gives me negative 6 over 4. Negative 4. 2 negatives give me a positive. Gives me a 3/2 for my x value. So I know my asymptote. I'm going to change that 3/2 to 1 1/2 into a mixed number. Then I get a better idea of where to put my graph here. So how far away is this dot from here? It's 1 1/2. So I know my other point is going to be 1 1/2 on this side. So yay, I found that. All right, now I need to find out where my vertex is. Where along this line is my point? So I take my 3/2, plug it into the original equation up here. So let's get rid of a bunch of stuff here. I know my x value was 3/2. So I'm going to rewrite this as y equals negative 2 times 3/2 squared plus 6 times 3/2 minus 5. Fun. Okay, let's multiply the first. 18 over 2 is 9 minus 5. So y equals negative, well, that'd be 9/2 reduced. This would give me plus 4. And then common denominators. This is why you learned all of that. So y equals negative 1/2. So that being the case, I just look here at negative 1/2, which is right there between 0 and negative 1. So it's going to be right there. And now it's very easy for me to draw this. And remember, it goes down because this number here is negative. So not too bad. All right. So I'm going to stop there. The next couple are story problems. Not going to deal with those right now, but I do want you to look at the bottom of page 619. And I'm not going to go into this. The book doesn't go into it yet. They will later. But the graph of a parabola, or the changed equation of a parabola, remember at the beginning I said was this. Okay. If we use completing the square on that, we will get this. Okay? Where H and K are the vertexes, or is the vertex. Okay, so there's some things we're going to get into later. I don't know why the book showed that to you, but this is a special formula derived from this formula using completing the square, and I'm not going to go over the massive complication of going from here to here, but we will later. And when you have it in this format, it makes it real easy. Right there is the vertex HK, and there's a lot of other things that you can find out based on this information. This is a positive, so you know that the parabola is going to open up. If this were negative, it would open down. So that rule still applies, but there's just some good stuff you can get out of it when it's written in that way. But we're not going to do that right now. So anyway, take what you've got and continue 7.5.